my name is Jeff Couch. First off, I'll preface this with I am the educational sales manager for the West, so I am not a developer. Our developer who runs Sphero Edu, his wife is expecting a baby any day now, so he asked me to come in his stead. So I apologize if there's any really technical questions. I'm the stupid sales guy, so I probably won't be able to answer them. But here's my contact information. If you send me any questions you want to know about Sphero Edu, I can certainly pass that on to the team to be able to get the information. By quick raise of hands, anybody in here not familiar with Sphero Edu or Sphero as a whole? Okay, awesome. I'm going to blow through this real quick, and then I'll be here with the rest of the day. But basically, this is our latest robot. It's a little programmable robot. The kids learn how to do JavaScript doing it, using this little robot. And I'm going to walk through really fast. I'll go through this and then give you a quick hands-on demo showing what we do. But basically, Sphero Edu, there's three components to the program. There's the robot itself. You need the physical robot so the kids can see what they're programming. There's the programs themselves. That's where the kids go in and they write JavaScript. There's three different ways. I'll show that. And then there's activities where in the app, we have an app here where we pre-design lesson plans so the teachers who don't know how to program can go in and find relevant content, supplemental content to what they're teaching already in their classrooms. Literally from pre-K level through university level, we have students using Sphero Edu. So the main thing I'm going to talk about today is the Sphero Edu app. So if you're familiar with Sphero already, if you have one, I know some of you in the room already have Spheros. If you're not familiar with this app, go ahead and download the app. You can go in and use any of the activities. It's completely free. But there's actually three different ways that learners progress through our system. So we start with draw, where they can go in literally on a blank canvas. They can draw an image and then hit run, and then the robot will do what they drew, right? And behind the scenes, it's actually JavaScript running the robot. But learners as young as 4 or 5 years old can be drawing different patterns, different shapes, and learning computational thinking and working their way through. The majority of the users worldwide are using blocks. It's a Scratch environment. We just transitioned to Scratch this June, so we're pretty new with Scratch. But that's the majority of the users are using Scratch in our block environment, and I'll be demonstrating that here in a little bit as well. And then we get to the point where they can actually be typing in JavaScript in a blank JavaScript canvas. And we have like Air Force Academy doing a full semester of JavaScript just using this robot now. So in the platform itself, here's a quick example, and this is designed by Workbench, actually. We have Workbench here in the room. In the app itself here, we have the pre-designed lesson plans where teachers can go in and navigate and find, again, the relevant content that they're looking for to supplement what they're teaching already in the classroom. I'm going to go through really fast, giving you an idea of what this little robot can do. Here's a few different, I'm going to go through the STEAM acronym, which in schools right now, STEM or STEAM is really big, right? Demonstrate a few of the activities. We have hundreds of lesson plans in there, but the top one being, a class might be doing a unit on the planetary or on the solar system and talking about planetary motion. And so this is just demonstrating how the planets orbit the sun, right? And so the kids would literally program the orbital path for their individual planet, and one representing the sun. Second one here, long jump, where they can go through and program or drive or do whatever they want to do, and talk about different math concepts, physics, science, physics concepts, things like that in a long jump. And each of these you'll see tie with individual educational standards as well. Second one, technology. The Strawn Beast, if you're familiar with the Strawn Beast, it's a guy in I believe it was Norway, created this big windmill. And a student was doing a unit on transfer of energy. And so he took Sphero and used it as the driving force in he created his own Strawn Beast doing 3D printing and all of that, and then just programmed Sphero to go back and forth, being the driving force on it, right? And then obviously programming, fitting along right with technology. Engineering, we do a lot with engineering challenges, especially in younger ages, where not only the kids involved in programming, but they're also involved in a maker project, right? They take maker materials, they build their own type of chariot. The bottom one there is a hydro hypothesis where they build some type of flotation device, some type of ship to transport materials from one side of a pool to the other. And again, use Sphero as the driving force behind that chariot or that boat. Done that, you know, some of these, again, as young as kindergarten students learning how to do this. Art. Art, storytelling. I'm going to demonstrate this a little bit more. The top one is a storytelling one. I'm going to show a real world use case of what some students have done with storytelling using Sphero. Again, doing block coding through it. And then painting, kids can create their own paint. The robots are waterproof and paint proof. And so the kids can program their own, you know, Jackson Pollock type painting. A lot of fun. And then the last one with the STEAM acronym is obviously math. Pretty much everything you do in programming and using Sphero, you're using math, and oftentimes the kids don't even understand that they're using math. And so later when they go to their math class and they talk about different concepts, they're already familiar with them, which is a lot of fun. This maze, again, can be used literally from kindergarten age all the way through university level with the different skill levels. It doesn't matter how good or whatnot with it. We are basically device agnostic. Coming out in just a few weeks, we'll be Windows compatible. We'll have a Windows app coming out. But right now, Chromebooks, iPads, iMacs, or MacBooks, you know, your mobile devices, anything like that, you can use using Sphero. So what I'm going to do is I'm going to hop out here, and I am going to open up the app itself. Okay. I'm going to demonstrate really quick on how to program it. So whoops. So all I'm doing is connecting to this robot that I've got up here. Give it a second here. Hopefully our Bluetooth's okay. There we go. So once I did that, the robot turns on. So what I'm going to do is I'm going to go and quickly create a new program. And when I create a program, I can do, again, the draw, I can do the block or the text, right? Obviously here we're going to talk about the blocks, and I can select which robot. We have a plethora of robots that you can use, but Bolt is this new one. So what I'm going to do is I'm going to create a new block canvas here. Okay. So I don't know why I can't, whoops, there we go. Okay. Sorry. Whoops. All right, so down here is where I can go through, you know, my movements, my lights, my sounds, controls, and get really technical over here with building my own variables, building my own functions, things like that. I'll demonstrate some of the comparators and operators and things like that. But simple roll commands where I just drag up a roll command here. I give it a direction that I want it to go. I set a speed, the binary scale of 0 to 255. Which that is for kids is the hardest thing to understand. They always think, especially the boys, always think it's 255 miles per hour. And the boys will always hit 255 and then go like this, 99999, and try and maximize the speed and distance that it's going to travel. But that's simply how I tell the robot to move. I set a heading, a speed, and a time. There is no distance setting. The kids have to figure out all these things on their own. And go through and add lights and sounds and all this, and I'll demonstrate this. So what I'm going to do right now is we're going to build, we have an activity in here, what we call animal toss, right? Where it's like the hot potato game where I can throw the robot back and forth and acting like the hot potato. But what we're going to do is I'm going to demonstrate how to build the animal toss. So first thing I'm going to do is I'm going to, just so it will run, there's a stabilizer in here. I'm going to turn the stabilizer off, right? And then what I'm going to do is I'm going to type a speak block in here and say, let's play the toss game. Okay. And then over here, I'm going to add a loop. We're going to do a loop forever. Oops. And then inside of that loop, I'm going to do an if then else statement. Okay, and then I'm going to go over, and I know I'm doing this really quick, but I think everybody in this room understands what's going on so far, right? So I'm going to do a comparator. I'm going to create a greater than comparator here. And then we're going to use, inside the robot, there's actually an accelerometer. So now I can tell the accelerometer, so if the accelerometer is greater than 3 Gs, Then I want it to do, I'm going to have it change the main LED light. We'll change it to green if it goes above 3 Gs. And then I will tell it to play a random animal sound. Then go in here quick, do a random animal sound. See if and then I'm going to, if it does not meet that 3G threshold, I'm going to tell it to turn the LED light to red. And then the fun thing with this is, as the students are doing this, I can go in here and actually look at the JavaScript line by line. And so this is makes it really easy for the kids to start to digest how to actually code, right? Oftentimes kids are pretty familiar with the Scratch environment with Hour of Code or different activities they're doing throughout the school year. But now I can look at, as I add a line of code, I can look at the actual JavaScript and really start to understand what I'm really doing. And then they simply hit start here. And then I don't know if it'll play the sound. The sound's not playing, but then I would throw it up and you can see the light turns green and it would play a random animal sound. The kids have to guess the animal sound and then throw it back and forth, right? But it's just a fun activity for them to learn how to code and then do a fun game activity with it. But this is exactly how, in all those activities that I just showed, going through that STEAM acronym, this is how the kids would code their way through those activities, right? Just a simple block environment. Each of these can be done with. Also, the cool thing here with it is whenever it is running behind the scenes, I can actually get actual data behind it as well. So it shows orientation, gyroscope, accelerometer, all this data, so they can go in and do some really cool data analytics as well inside the system. So any questions there?
So this is part of the Sphero Edu program. Is this also available to consumers?
Yes. Yep. So Sphero Edu is a free app that anybody can download at any time. So yeah. And I think that's it. I tried to blow through this really quick so we can try and get back on time. Any other questions? If you have something, yes. Here. Oh, here we go.
So we make a online learning environment. What kind of integration could we with Sphero?
That is a great question that I'd have to direct you to Bill and his team on the different integrations that we would need to do. Yeah, I'm not involved with that at all. I just sell the things. Good. Well, if there's no other questions, I've got robots here later during lunch, during breaks, or whatever you want to play with some, please feel free. Come ask me questions later and that'll be great. Awesome. Thank you.